6, 5, 3, 2, 1.
Welcome back to NASA Now. Last week we flew with Global Hawk. This week we'll meet R2. Hi, I'm Chris, and here's what's happening at NASA now.
From October 4th through the 10th, 55 nations of the Earth will join in the celebration of World Space Week, the largest annual space-oriented event in history. Begun in 1999 by the United Nations General Assembly, World Space Week is an international celebration of science and technology. This year's theme is Mysteries of the Cosmos, which is all about the nature of the galaxies and stars, as well as with the nature of life itself.
That's NASA Now. Now, let's flash forward to the past.
Back in the spring of 1961, the world's first working robot joined the automobile assembly line at General Motors. Well, now, just 49 years in the future, General Motors has partnered with NASA to develop a robotic assistant that is scheduled to join the human team on the International Space Station.
How's that for a success story? Now, let's see and hear some more.
We can build a machine that's capable of doing a lot of things on its own. Tactile sensors on its fingers that allow it to have a sense of touch. It can use autonomous vision capability. I'm Josh Mailing, the lead mechanical engineer for the Robonaut project here at Johnson Space Center in Houston, Texas. Robonaut 2 is loaded inside the payload bay of the Space Shuttle Discovery right now, and it will be the first humanoid robot to be sent into space. And in fact, it will also be the first United States robot that will be sent to the space station. The thing that sets Robonaut 2 apart from most other robots in the world is a real fine dexterity and a sense of the world around it. So not only does it have cameras to see what it's working on, but it also has a very refined sense of touch. The joints have wider ranges of motion than people do, and the vision system has multiple cameras in multiple different places rather than just two eyes. And so we can augment capability to make the robot useful in multiple different ways. Robonaut 2 was designed to be an astronaut assistant. If you look at the world around us, it's designed for humans. And Robonaut 2 is designed to be able to interact with that environment. If you extend that vision to what NASA astronauts are going to be doing, you start to see robots taking over the tasks that the astronauts don't want to do, or the astronauts could use an extra set of hands. So it's not replacing astronauts so much as it's giving them another tool in their toolbox. The Robonaut 2 can be controlled in a variety of different ways. You can control the robot sitting right next to it by punching commands into a laptop. You can be down here at mission control and have the robot on orbit sending commands in much the same way. The robot also has the capability to be controlled through virtual reality equipment. The original Robonaut was started in the late 90s, and it served as a development platform for a lot of the advanced dexterous ability that we see in Robonaut 2 now. In 2007, we had a group of engineers from General Motors come down and embed themselves with our team here at NASA. And together, we started work on the design of the robot. My background in robotics, I think, really starts with me playing with Legos as a kid. I was always interested in the way things moved and how they worked. I got interested in robots through the first robotics program as a high schooler. And once I did that, I was pretty much hooked. As we think about future space travel and all of the fanciful science fiction ideas out there of robots working with people, that's not really as far off as we think when we watch those movies. The best piece of advice I could give anyone who's interested in robots and wants to work in robotics is to not lose that fascination with the way things work and how you can invent and come up with new ways of doing things.
Take a note that on October 15th and 22nd, Robonaut will answer your questions online in a live Twitter view. Stay tuned to NASA Now for more information.
Now, from robotic astronauts to laser light shows.
Look, up in the sky, laser beams. Attack from outer space? No, these lasers are being used to track the Lunar Reconnaissance Orbiter, or LRO, a minivan-sized satellite circling the Moon 250,000 miles away from Earth and traveling at a velocity of 3,600 miles per hour. The laser technology allows researchers to determine within 4 inches the satellite's exact distance from Earth. LRO is carefully mapping the surface of the Moon, looking for new landing sites amidst its many bumps and craters. It is critically important to know its position as accurately as possible so that it can create the most detailed and reliable maps. This beam is being shot from Laser Ranging Facility at Goddard's Geophysical and Astronomical Observatory in Greenbelt, Maryland. These folks are seeing quite a light show. Did you know that we'll be celebrating Earth Science Week together from October 11th through the 16th? This year's theme is exploring energy, and if you tune in to NASA Now during that time, we'll have a special program about the electromagnetic spectrum and how we can use and misuse the many forms of energy produced by our sun. Hope to see you then.
Now, it's your turn.
Test out your robotics skills with NASA's Robotics Alliance project. Go to robotics.nasa.gov for more information about events and registration.
And don't forget, there's still time to enter the contest I told you about last week. Deadline for the Earth Science Week Photography Contest is October 15th, and the last day for the Waitlist Challenge is November 1st. Well, that's it for NASA Now. Be sure to tune in next time when we celebrate Earth Science Week. See you then on NASA Now.